Welcome back children. We are moving on to the next session of diagrammatic presentation of data, that is frequency diagram. Frequency diagram consists of histogram, frequency polygon and ogives. Along with the frequency polygon, we will be learning frequency curve also. So, frequency diagram is the next topic that we are going to learn under diagrammatic presentation of data. We finished with bar diagrams and pie diagrams. Next is frequency diagram. So, histogram, frequency polygon and ogives come under frequency diagram. Now, let us first discuss with histogram. What is a histogram? A histogram is a graphical presentation of data of frequency distribution of a continuous series. You know what is a continuous series? The data given in the form of class intervals which assumes a range of values is known as continuous series. So, when your data is given in the form of a class interval, we call it as continuous series. In continuous series, you will be having the frequency. For such data, when we represent it in the form of a diagram, we call it as a histogram. So, what is a histogram? Histogram is a graphical presentation of frequency distribution of a continuous series. So, class interval and the frequency both will be represented in the histogram. Now, let us see important points with regard to histogram. In a histogram, the values are represented on the x-axis and their corresponding frequencies on the y-axis, which means the class intervals. The class intervals are marked on the x-axis and their corresponding frequencies are represented on the y-axis, because in the definition itself it is already clear that what is a histogram? Histogram represents both the class interval as well as frequency. It is a graphical representation of the frequency distribution of a continuous series. So, for such a series, the frequency will be marked on the y-axis and the class interval will be marked on the x-axis. If the data is given in inclusive series, convert it into exclusive series. An important point which has to be considered while drawing a histogram. If your given data is an inclusive series, convert it into exclusive series. And you have learned how to convert inclusive into exclusive series in your last chapter. Next is histograms are two-dimensional diagrams. What do you mean by that? Both the length and the breadth of the rectangle are considered for comparison. So, histograms also will be drawn in the form of bars. So, both the length as well as the breadth will be considered for comparison. That is why it is known as two-dimensional diagram. Next one, histograms are constructed for equal class interval as well as unequal class interval. So, histograms are constructed for equal class interval. You know what is an equal class interval? Example is 0 to 10, 10 to 20, 20 to 30, 30 to 40. Equal class interval. Everywhere the size of the class is the same. It is also constructed for unequal class interval. Example for unequal class interval is 0 to 10, 10 to 20, 20 to 40, 40 to 80, it is unequal class interval. So, we construct histogram for both equal class interval as well as for unequal class interval. You have learned about the difference between equal class interval and unequal class interval in your last chapter. Now, let us first start with histogram of equal class interval. So, I hope it is clear to you. Histogram. In the histogram, the values of the class intervals are represented on the x-axis, corresponding frequencies on the y-axis. If data is given in inclusive, convert it into exclusive. Now, it is a two-dimensional diagram because both length and the breadth are considered for comparison. Then, histogram are constructed for equal and unequal class interval. Let us first move on to histogram of equal class interval. Now, here you can find the example where marks given with 0 to 10, 10 to 20, 20 to 30. This is a continuous series, right, with frequency given on the other side. Now, 0 to 10, 10 to 20, 20 to 30, 30 to 40 till 60 to 70, the frequency is given as follows. Now, we are going to represent this in the form of a histogram. This is how we have represented, where marks is given on the x-axis and number of students is given on the y-axis, because we have already told that the frequency should be marked on the y-axis. Now with the information, I have marked it. Let us see what is it. 0 to 10, it is 5. 10 to 20, the value is 10. So it will be 0 to 10, 5, 0 to 10, it is 5, 10 to 20, it is 10, the value is 10, then 20 to 30, 20 to 30, the value is 15, 20 to 30, the value is 15. So I have constructed, the bars are constructed, but one difference you can find from the bar diagram. In the bar diagram, for each bar, a space is left in between. For a histogram, it's not there. All the bars are drawn attached together. That is a difference between bar diagram and a histogram. Now, in the histogram, in this example, next 30 to 40, the value given is 20. I have constructed the bar with 20. 30 to 40, the height of the bar is 20. And the top of each bar I have written the value. This is a histogram. So this is how we construct a histogram of equal class interval. So simple as that. Depict the values in the form of bars where one is attached to the other one. Now we can move to the next one, the histogram with unequal class interval. Here the class interval is not equal. So what has to be done here? Frequency of unequal class interval has to be adjusted. So what is the example I have given for unequal class interval? 0 to 10, 10 to 20, 20 to 40, 40 to 80. All this is an example of unequal class interval. So the frequencies of unequal class interval has to be adjusted. That is known as adjustment factor. So that is known as adjustment factor. So how will you find out that adjustment factor? Adjustment factor of any class interval is equal to class interval of the concerned class by the lowest class interval. Once again I repeat, as it is an unequal class interval, frequencies have to get adjusted of unequal class interval. Therefore, that is known as adjustment factor. Adjustment factor of any class interval is equal to class interval of the concerned class by lowest class interval. Each class will have its own class interval. That is divided by the lowest class interval of that series. Anyway, it is an unequal class interval. Therefore, each class will have a different class interval, or one or two will be having the same class interval. After that, there will be different class intervals. So, take the class interval of each class and divide it by the lowest class interval of that given series. Now, I will make you understand with the help of an example. This is an example where the data is given as 10 to 15, 15 to 20, 20 to 25, 25 to 30. Till here the class interval, the size is 5. After that it is going to be unequal. 30 to 40, the difference is 10. 40 to 60, the difference is 20. 60 to 80, the difference is 20. So there is unequal class interval. Therefore, frequencies need to get adjusted. Now we are going to move on to adjustment factor. So I have framed out the table in such a way that this is the initial table and this is the new table with adjustment factor. Okay. Now 10 to 15, it is 7. 15 to 20, the frequency is 10. 20 to 25, the frequency is 27. 25 to 30, the frequency is 15. How to find out the adjustment factor? Now 30 to 40, it is 12. Again 40 to 60, the frequency is 12. 60 to 80, the frequency is 8. Now how to find out the adjustment factor? Adjustment factor is the class interval of the concerned class by the lowest class interval. Which is the lowest class interval here? Definitely it is 5, because for the first 3 it is 5 and the next one it is for the next 3. First 4 it is 5, and for the next 3 it is with a difference of 40 to 60, 30 to 40, 10, 40 to 60 it is 20, and here the size is 5. Okay. So, first 4, 10 to 15, 15 to 20, 20 to 25, 25 to 30, the difference of the class is 5. Then 30 to 40, difference of the class is 10. Then 40 to 60, 60 to 80. For the next 2, the difference of the class is 20. Now, adjustment factor, we will find the formula for adjustment factor is class interval of the concerned class by lowest class interval. What is the class interval of the concerned class of the first class interval? This is the first class interval 10 to 15. This is a concerned class. By the lowest class interval, which is the lowest class size, 20 or 10 or 5, definitely it is 5. So, which is the class size of the first class? 5. Which is the lowest class interval in general? 5. So, 5 by 5 is equal to 1. Next, 15 to 20, what is the size of the class? 5. What is the general lowest class interval? It is 5. 5 by 5 is equal to 1. Next, 20 to 25, what is the size of the class? 5. 5 divided by lowest class interval, which is the lowest class interval? 5. It is equal to 1. Likewise, the next one also, the value is 1. And let us move on to the next 30 to 40. What is the size of the class? It is 10. 10 divided by lowest class interval will be always the same, 5. 10 by 5 is equal to 2. Next class 40 to 60. What is the class size? 20. Now, divided by lowest class interval, which is the lowest class interval? 5. 20 by 5 is equal to 4. So, with the adjustment factor, we have written the corresponding frequency 1, 7, again 1, the next frequency 10, again 1, the next frequency 27. Okay, again next 1, the frequency as 15, next 2, the frequency as, see, 10 divided by 5 is equal to 2, isn't it? 10 divided by is equal to 2. Now, the frequency density 5 divided by 5, 1, and the frequency density can be found with 7 divided by 1 is equal to 7. 10 divided by this adjustment factor 10, 27 divided by this adjustment factor 27, then 15 divided by 1 this adjustment factor 15. Okay, so till here as it is 1, you will get the same value of frequency as 7, 10, 27 and 15. Now the value of frequency density is going to change. How it is going to change? Here the frequency is 12. Here the adjustment factor is 12. So, 12 divided by 2, the new frequency density is 6. So, adjustment factor you are writing not the actual frequency, you will be writing the frequency density to be noted, not the frequency density. For the first 4 values, it remains to be same with that of frequency because your adjustment factor is 1 only. Then comes the next one, that is 12 as the frequency divided by the adjustment factor here is 4. So, 12 divided by 4 is equal to 3. Then comes the next frequency 8 from the table, adjustment factor is 4, 8 divided by 4 is equal to 2, that is the new adjustment factor. So, this is a new table that we are going to frame out with the adjustment factor and the frequency density. Now, we are going to depict the values on the graph. How will you depict the values? While depicting the values, how will we mark the x-axis as well as the y-axis? We have to mark it as 5, 10, 15, 20, 25 till 80. Then your y-axis will be from 5, 10, 15, 20 because it represents the number of workers. Number of workers, you know, it is frequency because we have already told that in a histogram number of workers or frequency will be marked on the y-axis. Okay. Now, how will we mark it? 10 to 15 is the first class interval. 10 to 15 is the first class interval in your question. Now which is a new frequency density here, it is 7. Now with not the frequency we are not going to mark, with frequency density we are going to mark, because initially we have told in a histogram, for constructing a histogram, if it is an unequal class interval, adjust the frequency. So we have to mark the frequency density, that is the new frequency which we have got. Okay, so we are going to mark the class interval 10 to 15 not with the frequency but with the frequency density we have made with adjustment factor. So 10 to 15 it is 7, that is why I have marked it as 10 to 15 as 7. Then obviously 15 to 20 is the next class, 15 to 20 is the next class, you will be marking the value 10. Okay, not this exact frequency but the new frequency density. Here the values are remaining to be the same because your adjustment factor is 1 till the class interval 25 to 30. Okay, so we have marked it as 10. Then comes 20 to 25, it is 27, 25 to 30, again 15. Next is 30 to 40, your class interval is changed from 30 to 40. Your adjustment factor is 2 and your frequency density is 6. Therefore, 30 to 40 I will be marking it as 6. So, 30 to 40 and I have marked it as 6. Then comes the next one. Here 40 to 60 is the next one. So, here on the x-axis you have to represent from 40 to 60. Here the width of the bar and the length of the bar will be considered for comparison. So 40 to 60 is the next class. There we will be considering the frequency density, not the frequency. It is 3, that is why I have marked it with 3. 3 is the height of the histogram. Okay, so this is how, and the last one is 2, that is 60 to 80, which is 2. This is how we construct a histogram with unequal class interval by finding the frequency density and with the adjustment factor. I hope it is clear to you, histogram with equal class interval and unequal class interval. Okay, now we will move on to the next frequency diagram, that is frequency polygon. What is a frequency polygon? Frequency polygon is formed by joining the midpoints of all the rectangles of a histogram. Frequency polygon is nothing. It is just drawing a histogram and the midpoints of that bars after drawing the histogram will be connected. That is all about the frequency polygon. So, frequency polygon is formed by joining the midpoints of all the rectangles of a histogram. So, we have to draw the histogram first and you have to mark the midpoint from the bars. A frequency polygon can be constructed with histogram and without histogram. So, frequency polygon can be constructed with histogram as well as without histogram. So, what is a frequency polygon? Frequency polygon is a graph which is formed by joining the midpoints of the bars of a histogram. And it is not necessary that you have to draw a histogram. You can construct a frequency polygon either by drawing the histogram or not by drawing the histogram or without the histogram. Let us see the frequency polygon with histogram and without histogram. So, first we will do frequency polygon with histogram. Frequency polygon with histogram, here marks are given as 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Now, number of students 5, 10, 15, 20, 12, 8, 5. You can easily represent it with the help of a histogram. This is the histogram. Now, here I have marked 0, 10, 20, 30, 40, the classes and the frequency, number of students. Number of students is the frequency is marked on the y-axis because already we know that for histogram the frequency should be marked on the y-axis. Now, based on the information I have drawn the histograms here. Now let us see whether I have drawn it properly. 0 to 10, 5, 10 to 20, 10. 0 to 10, the value is 5. 0 to 10, the value is 5. 10 to 20, the height of the bar is 10. Again from 20 to 30, 20 to 30, height of the bar should be 15. 20 to 30, height of the bar should be 15. Yes, 15. 30 to 40, height of the bar should be 20. 30 to 40, height of the bar should be 20. Likewise, I have drawn the histogram. After that, how will you draw the frequency polygon? Frequency polygon is drawn by joining the midpoints of the bars of the histogram. Bars of the histogram. We have taken the midpoints. After that, use a scale and then connect it. This is known as a histogram. Use a scale and then connect it. That is known as a histogram. So, for drawing the frequency polygon, you have to draw a histogram first and then from that bars drawn, take the midpoints, using a scale, join that, then you will get a frequency polygon. This is how we draw the frequency polygon with the help of a histogram. You can draw the frequency polygon without a histogram. Let us see how we can draw a frequency polygon without a histogram. Frequency polygon without a histogram. What has to be done? Here, the mid values of the classes of a frequency distribution are marked on the x-axis of the graph. Then the corresponding frequencies are marked on the y-axis. So, here the class intervals are not taken into consideration. Instead of that, we will be converting the class intervals to mid values. On the basis of the mid values, we will be marking the corresponding frequencies. Let us see how. This is the initial data. If it was frequency polygon with histogram, what are we supposed to do? 10 to 20 we will mark 10, then 20 to 30 we will construct a rectangle bar for 15, then 30 to 40 we will construct a rectangular bar with 20. This is how we do if it is a histogram with, if it is a frequency polygon with histogram. Without histogram, what has to be done? You have to convert this class interval to mid values. That is what is explained here. Here mid values of the classes of a frequency distribution are marked on the x-axis. So, here 10 to 20, what is the mid value of 10 to 20? 10 plus 20 by 2, that is a mid value. What is 10 plus 20? 30. 30 by 2 is equal to 15. So, first mid value is 15. Again 20 plus 30, 50 divided by 2, 25. Again 30 plus 40 divided by 2. That is how we find the mid value. What is the formula to find out mid value? L1 plus L2 divided by 2. That is lower limit plus upper limit divided by 2. 70 by 2 you will be getting 35. Again 40 plus 50, 90 divided by 2 you will be getting 45. So, here you have to convert the class into mid values and then mark the corresponding frequency. We are not going to change the frequency, it is same as it is, but we are changing the class interval to mid values. Now, based on the mid values, this is a new table that we have framed. Now, on the basis of this table only, we are going to draw the frequency polygon. See. And in this frequency polygon, we can find 15 and 10. For 15 will be marked on the x-axis and frequency will be definitely marked on the y-axis. So, what is the value of 15? 15, 10. Then comes the next one. For 25, it is 15. 25, it is 15. Then the next one is 35. For 35, it is 20. For 35, it is 20. Again, the next one is 45. For 45, it is 22. For 45, it is 22. Again, for 55, it is 15. And for 65, it is 10. After marking this midpoints with the frequency, use a scale and connect these points, you will get the frequency polygon. This is the frequency polygon. So, if it is a frequency polygon without a histogram, convert the class interval to mid value, and with that mid value and the corresponding frequency, the data has to be marked in the graph. This is how we get a frequency polygon without a histogram. So, when you are asked to construct a frequency polygon with histogram, use the class interval and the frequency. If you are asked to construct a frequency polygon without a histogram, convert the class interval to mid value. With the frequency, you can construct a frequency polygon. Now, we are going to move on to the next part of the frequency diagram, that is frequency curve. So, histogram, frequency polygon and frequency curve. Now, only a small difference is there between a frequency polygon and a frequency curve. Both frequency polygon and the frequency curve we can draw with a histogram. Now, what is the basic difference? Now, for drawing a frequency polygon with a histogram, we will be drawing the histogram first, and then we will be taking the mid value of the bars, and then using a scale we will join those points, right? But in a frequency curve, we need not use a scale. Instead of that, you can join those midpoints of the bars using a free hand. So, it will be a free hand smooth curve. That is known as a frequency curve. This is the only basic difference between frequency polygon and a frequency curve. So, when you have a look at the frequency polygon, you will be able to know it is drawn with a scale, where you use a scale and with the scale you will be drawing it. But whereas a frequency curve, you will be joining the midpoints of the bars using a free hand. So, it will be a free hand curve. That is the only difference. Now, the frequency curve, an example I have given, age 0 to 10, number of students 150. So, from 0 to 10 I have given till 70 to 80. Now, I have represented this with the help of a histogram. So, I have drawn this with the help of a histogram. First, you have to construct the histogram if it is a frequency polygon and a frequency curve. Now, 0 to 10, the value is 150. I have marked it as 150. 150, height of the bar is 150. 10 to 20, the height of the bar is 300. I have marked it as 300. This is the height of the bar and that is 300. Again, 20 to 30, the height of the bar is 500. So, I have constructed the histogram, and after that the midpoints of each bars is marked. Midpoints of each bars is marked. After that, what is done here is using the hand, I have just connected these points and made a curve. This is known as a frequency curve. So, frequency curve is a free hand, smooth curve, So, on the top you can find it is not pointed. If it is a frequency polygon, it will be a pointed ones, but here a frequency curve will not be a pointed one, it will be freehand smooth curve. This is the only basic difference between frequency polygon and a frequency curve. So, hope it is clear to you all the three diagrammatic representation of data, that is frequency diagram. In that frequency diagram we have discussed histogram, then frequency polygon and frequency curve. Thank you.